The point of this video is to show you what happens when you make a mistake. Because here in substitution, and in fact, in a lot of integrals, like we're not doing any crazy integrals in this class, but like if you really go down the road of integrating, there are some really nasty integrals, and it's like a puzzle. It's like problem solving. You're never really gonna get your guess right on the first try because there's a lot of different methods. So it's okay and expected for you to start and fail and then start again until you succeed. That's what this video is all about, showing what that looks like, what to look for, how to recognize things. And so let's go. So this first problem, let's try to follow the integration method and see how it goes. So this one's a little weird because we don't really have an inside function. When I think of chain rule, I don't really see anything to chain rule, but we can't take the integral right now. There's no quotient rule for integration. So if you have a quotient here, you're going to have a bad time. We can't just take the integral of each of these individually. We're going to need to use a substitution here. But it's not obvious what our u is going to be. So remember in the last videos, I said something to look for when you choose your u is we want the derivative of u to be somewhere on the top. And here we didn't have the -2, but yeah, mostly we had the derivative up there. Here, if we had the derivative of u up here, which was good. So we're hoping that this might be the derivative of u. So what should u be so that its derivative has something to do with an x squared? Well, let's just try this. The reason why we choose this is, okay, it's the whole denominator. That's nice. And if we take the derivative of u, we get something with an x squared in it, which might work out because we're going to need to substitute that x squared away. So if we do that, again, we'll get du is du dx times dx. And the derivative of u with respect to x is 3x squared. So that tells us that du is just 3x squared dx. Oh, that is almost really nice. All we need is a 3 here, and we get a du. Last time I compensated by just putting it out here, but usually we're going to compensate by multiplying the whole thing by a third. Multiplying by 3 and multiplying by a third, they cancel out. We haven't changed the problem. It's the same problem, just written a little differently. This is usually how we'll do it. So we have 1/3 times the integral. Now notice that this guy right here is exactly what du is. So our numerator is just du. What's our denominator? Well, this right here is exactly u. Our denominator is exactly u, and we have a much simpler integral now. And I'm going to do an optional rewriting step just because this is how my brain works. Write this as the integral of 1/u du. And let's say you use the power rule. You say, okay, this is u to the -1. So we're going to add a power, u to the 0, and divide by that power. That's not good. We do not want to divide by 0. Something went wrong. Remember from your power rule, we can use the power rule for any exponent for integrals, any exponent except -1. This is actually not the power rule at all. This was that natural log rule. Remember back to the previous section 3.3, this is the natural log of the absolute value of u. And now we just put everything back in terms of x's and we're okay. Again, it's okay to make mistakes. Just erase it once you realize it. We get a divide by 0 error. Yeah, that's going to be a red flag. U, we said, was x cubed plus 5. And we get this as our antiderivative. Let's get another practice with doing something wrong. Because again, you're going to be making mistakes on these integrals. How do you recognize that you made a mistake? And how do you fix it? So again, we have a fraction here. There's no quotient rule for integrals really. So we're going to try the only tool that we have right now. Later on, you could have more methods. We're not going to cover them in this class, but you could. Let's try, well, it looks pretty similar to the last problem. So let's just let u be, I don't know. Wait, should we let u be the denominator or the numerator? Because u in the denominator is what we did last time. U in the numerator might work though, because the derivative of x cubed is x squared. So if we let u be the numerator, right, then we get du is du dx times dx. That's 3x squared dx. But we have a problem here. Even if we divide by 3 and multiply by 3, the dx is not in the denominator. This is dx over 1. Dx is in the wrong place, or the 3x squared is in the wrong place, really. This is not going to work. This is not together. We cannot substitute. Similarly, if you let u be the other part, if you let u be the denominator, you would also have a problem. In fact, in this case, you can try it. What happens if u is the denominator? If u is x squared, you get du dx. Sorry, trying to be consistent with this class's notation. You get that du is 2x dx. But that's also a problem because there's no way of getting rid of this other x. We can get rid of an x, but we have an x cubed. So this is still a problem and our substitution's not going to work. And in fact, this is a bit of a trick question. This is not a substitution problem at all. So watch out when you're doing these things. Those are some of the things that can pop up. When you're solving these integrals, when you're evaluating these integrals, watch out for some of those issues. That's the point of this video, is to show you what it might look like if things don't work. And this is, we're actually going to use a different method to evaluate this integral. We're going to simplify the inside first. Remember that if you have addition on the bottom, right? If you have something like this, you can't break this up, right? This is not a third plus a fourth. Specifically, it is a seventh. But if you have addition on the top of a fraction, you can split it up. So this really is the integral of x cubed over x squared plus 5 over x squared dx. And now we can integrate, because we can simplify a little further. X cubed is x times x times x. X squared is x times x. Most of those x's are canceling. And the second one is 5 times x to the negative 2. Now we just use the power rule, right? This is like an exponent of positive 1. Add an exponent, divide by the exponent. Add an exponent, divide by the exponent, plus c. We'll simplify this a little bit. Dividing by 2 is the same as multiplying by a half. Dividing by -1 is the same as multiplying by -1. And then x to the negative first power brings it to the denominator. And we get this as our antiderivative. So be careful. It's okay to make mistakes. Try a few different things. Erase, that's totally fine. Use scratch paper if you're not sure. You're not sure it's going to work. Go off to the side. Go off to the side, use some scratch paper. Tons of strategies for dealing with this, but don't get disheartened. Messing up, choosing the wrong strategy is a very common thing for finding integrals. Derivatives You have rules and you just follow those rules. Integrals are more like puzzles, and you have to move some pieces around a little bit before figuring out how they fit together. So just expect that, and that's okay. It happens to me too. When I do some more complicated integrals, I'll say, maybe it's this or maybe it's this. Let's try something first and see how it looks. And then it'll either work or I'll go back and try something else. So good luck, and let me know if you have any questions. And I hope this was helpful.